By the definition, in example 1, find the derivative of f of x equals 5x cubed times sine x. If you notice, this is actually a product rule. Here is our u function, and here is our v. Now the product rule is u prime times v plus v prime times u. And that is valid when we have a product, taking the derivative of that. So if you notice, let's go ahead and write out u prime is 15x squared, and v prime is cosine x per our theorem above. So that f prime of x is u prime, that's 15x squared, times v, which is our sine x, plus v prime, that's cosine x, times u, which was 5x cubed, and I'm going to go ahead and write it as a coefficient. Less confusing that way. And there's our derivative. Now we could factor this, and I would strongly suggest doing that because there are plenty of times we want to find critical values and things that this is useful. So we can take out a 5x squared, which leaves us with 3 sine x, and an x cosine x. And that is our derivative. Example 2, find the derivative of f of x equals sine x cosine x. Again, another product rule. U and v. Applying that same definition, we have that f of x equals, well, we'll go ahead and write these over here. U prime is cosine x, and v prime is minus sine x, again, from our theorem. So u prime, so we'll have cosine x, u prime times v, which is cosine x, plus v prime, which is minus sine x, go ahead and put that in parentheses for this, times u, which is sine x. So it seems we have cosine squared x minus sine squared x as our derivative. Example 3, find the derivative of f of x equals sine x tangent x. Well, first we need to note that tangent is sine over cosine. So that this function is sine x times sine x over cosine x. Now, taking the derivative of this would be a bit of a trip because we would have a product and a quotient rule going on. So, I'm going to go ahead, well, actually, let's go ahead and do that. We're going to do this with a product and a quotient, although I'm going to rewrite this as sine x sine x over cosine x. Go ahead and do that. All right, so the derivative of our numerator. All right, let's see. I'm going to go ahead and say this up here, sine x. So the derivative of just our numerator. Let's go ahead and notate it that way. Will be, based on our product rule, sine x times cosine x plus, and then we'll have cosine x times sine x. So I'm going to go ahead and write it the same. So that this is 2 sine x cosine x. Okay, that's the derivative of our numerator. Derivative of our denominator is going to be minus sine x. So that makes our derivative. Well, I also need to write the quotient rule, don't I? So we've got a lot of reference material here. So our quotient rule, u over v, is low d high, so that's u prime times v minus high d low, that'll be u times v prime over low, or our denominator squared. So this means we're going to have u prime, that's our numerator, 2 sine x cosine x, times our denominator, which is cosine, minus our numerator, which is sine squared x, times v prime, okay, which v prime would be minus sine x, all over denominator squared, so cosine squared x. Okay, now we can rewrite that as 2 sine x cosine squared x, that's just writing the first term in the numerator, plus sine cubed x. Okay, all that over cosine squared. And we can factor the numerator to be a sine x, that would be 2 cosine squared x plus sine squared all over cosine squared x. And that is our derivative. It's as simplified as that's going to get, I believe. Example 4, find the derivative of f of x equals x plus cosine x quantity multiplied by quantity 1 minus sine x. Again, product rule. U and v. Our u prime will be 1 minus sine x. Our v prime will be 1, nope, not 1, just minus cosine x. So that f prime of x is u prime times v, so 1 minus sine x times v, 1 minus sine x, plus v prime times u, x plus cosine x. Let's see, we could distribute that just a bit. That'd be 1 minus 2 sine x plus sine squared x minus x cosine x minus cosine squared x. And I don't know if it's going to say it's any simpler than that, so that's how we'll leave it. Example 5, find the derivative of cosine x over 4x squared. Alright, well, this will be a quotient rule, and I've actually got that written up in the corner, so we'll go with that. U prime be the derivative of cosine, which is minus sine, and the derivative of our denominator would be 8x. So that g prime of x is u prime minus sine x times v, so times 4x squared, minus u, which is cosine x, times v prime, which is 8x, all over our denominator squared. Alright. I'm going to go ahead and factor out a 4x. 4x, so that will be, in fact, let's make that a minus 4x, so that we are left with x sine x plus a 2 cosine x all over 16x to the 4. Now that will simplify, of course. Take out the minus 4, the 4x, so this will be minus, let's go ahead and make that minus fraction x sine x plus 2 cosine x and that would be a 4x cubed. All right, example 6, find the derivative of x divided by cosine x. Again, this is a quotient rule. We get to use the same tricks over and over again. U prime is 1, v prime is minus sine x, so that f prime of x equals low d high, so cosine times the derivative, derivative of the numerator, so that's times 1, minus high d low, x times a minus sine x, all divided by low squared, so cosine squared x. Okay, so that would be cosine x plus x sine x over cosine squared x. And there's our derivative. All right, example 7. Find the derivative of f of x equals x sine x minus cosine x. All right, we do have a product rule built in here. Now the second part of that is just going to be, plus sine x. That's all we get for that. All right, so let's go ahead and write this out. We know we'll have our product rule, and the derivative of sine is negative, or cosine is negative sine, turning that from a minus to a plus. Now, here u prime is 1, v prime is cosine x. All right, so that will be x times cosine x plus the v prime times u prime, so that'd be 1. Make sure I'm saying that right. So that we have the first times the derivative of the second times the derivative of the first. So we have x times cosine x, so then there'll be sine times 1, so sine. So that would simplify to be x cosine x plus 2 sine x. All right, number 8. The position of a particle is given by s of t equals 2 sine t minus t for t between 0 and 2 pi. At what times is the particle at rest? When it's at rest is when the velocity is 0. So velocity is the derivative of position. So that means we have the derivative s prime is 2 cosine t minus 1. And we're going to set that equal to 0, which means that cosine t is equal to plus 1 divided by 2, 1/2, which we know that is true whenever t is pi thirds or 5 pi thirds. From our unit circle, back in section 1.3. And because we're bounded between 0 and 2 pi, these are the only two values of t where this will occur. All right, number 9, find the derivative of x squared times sine squared x. Now there are two ways to deal with this function. Okay. One is to write it as x squared times sine times sine. We could do that. It would be a product rule with 3 functions. Or if you did happen to know the derivative of sine squared, which I do, we actually found it earlier, we could actually use that as well. I'm going to go ahead and actually do a product rule with 3 functions. All right, since we haven't talked about the chain rule yet, that would be the best way probably. So this is x squared times sine x times sine x. Now we have yet to work with this, but the product rule with 3 functions is u prime times v times w plus u times v prime times w plus u times v times w prime. So effectively we take the derivative of each one at a time and sum those. So that is going to be 2x sine squared x, because that's the other two functions multiplied, plus x squared cosine x times sine x, taking the derivative of the middle term, and then taking the derivative of the last one, that'll be x squared times cosine times x squared times sine x times cosine x, which if you notice becomes 2x squared. Let's make that sine x cosine x. And that is our derivative.